So I'm trying to think of what the next kind of mini project is. I know I ultimately need to get the wheels turning, the primary motors running. And to do that, I need the Arduino Uno, which is going to be responsible for the motor controllers, to talk to the motor controllers. And I know how I had that set up previously, going back 2 years. Basically, it was the Android tablet, kind of the quote-unquote brain for RoVer, controlling the Arduino Mega, which is kind of the quote-unquote master, controlling the Arduino Uno, the slave. Not my terminology, but there it is. So that was the original setup, and I definitely want to get back there, but I think if I try to do it all at once, I'm going to get a bit overwhelmed with the complexity of it, at least complex for me. So I'm trying to kind of take it one step at a time. So I think the first step will be to get the Arduino Uno talking to one of the two primary motor controllers. So if we can succeed at that, then we can take the next step, which is for the Arduino Uno to talk to both motor controllers. And the reason why that's actually a complication is that the motor controllers are connected in series. They're not individually connected, so they don't individually talk to the Uno. The Uno actually talks to one motor controller, and motor controller 1 then relays information to motor controller 2, and it circles back through the first motor controller for feedback. So doing that requires a bit of kind of, for me, fancy wiring involving resistors and diodes, and I often forget which one is which. So that will be interesting. But yeah, so the first step I think is going to be to get the Arduino Uno talking to the first motor controller. And as we already know, that's going to involve triggering the relay to connect via the Uno, the shiftout, the relay, giving power to the motor controller, and we are also going to have to connect the primary battery, at least one of them, to the motor controller via the relay, so that the motor controller actually has power. So that's the plan. Also, it's important to note that the motor controller, in this case it's a RoboClaw 2x5 amp, is set up to either take power from, for the logic board power, it can either be drawn from the Arduino Uno for logic power, or it can use its onboard management MOSFET, I think, to take power from the primary battery. So the battery flowing into the motor controller to deliver power to the actual motor can also be used to drive the logic board power at 5 volts, which is actually a pretty nice convenience. The reason why I mention that is that's how I have it set up now, and to ensure that the actual motor controller has power, it needs to have power coming from the primary battery, regardless of whether or not we're actually driving the motor, since that's where it's getting the power for the logic board. So yeah, let's take a look. So to review the layout and exactly what we're trying to achieve here, we've got the Arduino Uno over here, and you'll remember, of course, that we've got the relays and the shiftout here. The main power source will come in through this black cable into the DC to DC power converter. We'll remember to keep it on this time, and that will flow power into one of the two primary motor controllers. The motor controllers are RoboClaws, and these are the two RoboClaws here, the red boards. I think you could make that out on the video. So that's the plan. We're going to be interfacing the Arduino with the RoboClaws via the breadboard, and I'll have to go over the wiring there. You can see that I've got a diode here and a resistor here from a previous attempt, which failed, probably mostly because I didn't have the power flowing in correctly. But that's basically the layout. That's what we need to figure out next. So let me take a look at the wiring and then I'll follow up with you. What I want to point out here is a schematic that a guy from the developers of the RoboClaw actually sent me when I couldn't figure out how exactly to wire this thing together. So basically what he explained was the master RX pin. So basically you've got what he's referring to as master and well, just master here is the Uno. So I didn't explain the whole mega Uno setup in the rover. So basically what he's referring to as the master RX pin is here referring to the Uno. So the RX meaning the receiving pin is connected to all three RoboClaw 1, RoboClaw 2, and the 5 volt. So between the RX pin and the 5 volt we've got a resistor, and between the RX pin and each of the two RoboClaws we have a individual diode. So yeah, so that's the setup. So now let's wire it. Well, so I got a bit of a sidetrack because when I went to take a look at the wiring, I noticed some frayed wire ends here in the RoboClaw. So I think it's from all the moving around and attempts at getting it to work previously. I just bent them back too many times. So these need to be replaced before I get any further. So let's tackle that. Okay, so we've got the wiring in place and I wanted to take you through it. So on the RoboClaw, and I'll show you a schematic. As you can see, we've got the RoboClaw diagram in the middle, and then over on the left hand side we've got what is kind of the representation of the circuits on the Arduino, in our case the Uno. And so if you focus on the center part of the diagram where you got the RoboClaw, at the very top you've got the S1 and S2. The only other two that we're interested in is the 5 volt and the ground. And as you'll find out in a second, the 5 volt we don't actually even have to worry about because we're getting the 5 volt logic power from the primary battery. So over on the right hand side you'll see that we've got the primary battery going into the RoboClaw as well, which is then going out into motor 1, motor 2. So for the purposes of our test right now we're doing just one motor test. Yeah, so basically the logic board on the RoboClaw is getting powered by the primary battery. So we don't even have to worry about the 5 volt DC that you see over on the left hand side from the Arduino on the far left. So what's critical in our case is getting the wiring for the TX, the transmission, and the RX. So we've got the out 1, out 2 that you see there. So that's when we actually get to the next step, which is connecting the two RoboClaws in series. But we're going to start with the one RoboClaw for the just kind of keeping things simple and getting through a successful test to start with. So we're connecting the S1 to the TX line on the Arduino, which in our case is going to be 10, pin 10. the pin 9 will be our RX. So you can see that the TX is going directly into the S1 pin on the RoboClaw. The S2 is going into the out. So that's what we've got the wiring done. And then the RoboClaw is also connected into the S1 via the diode. So let's take a look at the breadboard to see how that's wired. But we're looking at the RoboClaw that we're going to be controlling, and at the very top of that red board, you'll see from the left in, we've got yellow and then blue lines. Those are our S2 and S1 lines. And then next to those, we have the encoder 1 and encoder 2 that are connected to the two motors. So here we've got the wiring from the RoboClaw, and we're interested in these yellow and blue that are going into the breadboard. And then from the Arduino, we've got our 9 and 10 pins here going into the breadboard as well. And here you can see kind of a close-up. Basically, we've got the blue S1 pins. Basically, they're going direct from the Arduino to the RoboClaw. There's nothing between them, as if they would be wired together. And then the S2 pins basically have this 1K ohm diode between them. And the line on the diode, which you can barely see here, it's kind of lighter gray at this side, not this side. So that indicates that it's pointing to the RoboClaw. So the diode is directional, and you connect the RX pin from the Arduino, which is this white wire, into the diode, and then from the diode into the yellow S2 pin going into the RoboClaw. So I had mentioned that we were going to need the resistor, as you saw in the earlier video, but because we're actually powering the RoboClaw from the primary battery, which is over here, we're not going to need the resistor at all. We can test it, but that's my suspicion. That's kind of what I remember from previous. So here you can see we've got the two motors that we're testing with. So each RoboClaw controls two motors. So we've got two RoboClaws. We've got 4 motors total for ROVer. Right now we're working with 1 RoboClaw, so 2 motors. Here's our one of 2 lithium polymer battery packs. So we're going to connect that to the DC to DC converter, which is going to deliver power to the RoboClaw, which the RoboClaw is then going to send to the motors. So that's kind of the bigger picture. Now let's take a look at the code. Here we've got a sketch for the RoboClaw encoders. So to be specific, we're testing the encoders. We're not going to actually spin or rotate the motors themselves. I'll do that manually just with my fingers. What we're trying to test out is whether or not the Arduino is sending the instructions to the RoboClaw to read the encoders, and whether the RoboClaw is then reading the encoders and sending that back to the serial monitor on the Arduino Uno. So this sketch, and of course I'll include this on ROVer's website, takes you through the RoboClaw scripting. So here we have the address as 81. Basically you can have, I forget how many, but you can have a whole bunch of RoboClaws in series. This one's already pre-programmed as 81. The first is 80, so I guess the other one is set to being 80 on the other side of ROVer. And then we also need to, because of what we saw in previous videos, set it to, battery's about to die, so let's plug in. We also need to set the Arduino to instruct the shiftout to trigger the relay for the RoboClaw before we can actually do anything. So what we have here is some extra code in the RoboClaw script to set up the relay management. And then in the loop, we have here a if condition so that as we count through the different loops, when it's the first loop, so loop count 0, we'll trigger the latch pin on the relay. It just happens to be 80 here. 80, you'll remember, is the first relay, or I should say the last relay. So we're going to trigger the relay, and then we're going to go into the RoboClaw script, which will read encoders on the two motors. So we have motor 1, motor 2, and then we have encoders 1 and 2, and we're going to read the encoder value and the speed values. So speed meaning the change, so those we're going to see, the values there we're going to see change as I manually rotate the axle in the motor. And then the encoder values are actually also going to change, but they represent static values. So once I stop rotating either axle on the motor, we're going to see a new value for the encoders 1 and 2. What I'm going to do now is, we already have a lay of the land. I'm going to connect the one of two batteries here. So I just these Voltaic LiPos are awesome. Even have a battery status check, and one of the reasons why they were selected, I'll do a video on battery stuff specifically, but it also has a selection between 19, 16, or 12 volts, which is fantastic for a ROVer. So I have it set for 12 volts. I'm going to connect up the output to the DC to DC converter. Then we'll connect up the USB to the laptop to send the new sketch over to the Arduino, and then we'll have a look at the serial monitor to see what happens. We'll talk about the motors in more detail and this whole contraption that I've got on here, but in the meantime, so when I say that I'm just manually turning the motor, I just mean this. So as I'm doing this, we'll see what happens on the serial monitor. So now I'm going to plug in the power, which actually I've already plugged in the power, the main battery. Now I'm going to connect up the USB to the Arduino. We've got nice pretty lights. I won't bother showing you the pretty lights again. I set up this additional sketch here, all clear, just as a way of clearing the Arduino and quitting out of any processes. And we've got this RoboClaw sketch here that we're going to run. So we've already talked about the sketch itself. I'm going to hit the upload to send it to the Arduino Uno, and then I think you'll be able to hear the click of the relay flipping on. And then all we need to do is, as I showed, rotate the motors and have a look at the serial monitor, and fingers crossed. So uploading. And now we're waiting for the click on the relay. Awesome. So I don't know if you heard that, but that was a click on the relay. So we can see that we've got a success message. So now if we flip over to the serial monitor, wicked. So we have the Arduino sending at 1,000 milliseconds every second. So now all I'm going to do is rotate one of the motors, and we should see values change. So you can see that the encoder 1 and speed 1 is changing. And now if I do the same on the other motor, we see those values changing. So if I move in one direction, you see negative values, and if I move in the opposite direction, you see positive values for speed. This is awesome. I'm totally thrilled. Wicked. I'm not sure what else to say. The next step, I guess, well, let's talk about that. Yay! We've got the Arduino talking to the RoboClaw, and yeah, it's great to see that the the hardware is actually talking to the software. Yeah, I know it seems like a really small thing, but this is pretty big for me. We're kind of at we're really starting to see the finish line in the reviving ROVer saga. So the next step will be to connect up the two RoboClaws in series so that the Arduino Uno, the one board, can talk to both our RoboClaws, the RoboClaw motor controllers. And we can test to see that the Arduino Uno is receiving the encoder and speed values from all four motors. Once we know that the Arduino is actually communicating, and the test after that will be pretty cool. We'll actually send commands to rotate the motors. That'll be awesome. Start connecting wheels and get ROVer moving on his own. Okay, cool. Next project. Cheers.